first root. So first root is when our k is equal to 0, we obtain 1 plus I. So let's see what will happen when k is equal to 1. The second root we are going to find for that complex number we have. So we have z1 square root of 2. What are we going to change? We have pi plus 2 times 1 times pi over 4. Sorry, it is cosine of pi plus 2 pi over 4 plus I sine pi plus 2 pi over 4. From here we say with the square root of 2. So pi plus 2 pi will have cosine of 3 pi over 4 plus I sine, the same as pi plus 2 pi over 4, we have 3 pi over 4. So again, this angle 3 pi over 4, it is lying into the second quadrant. So our cosine will be negative while sine is still positive. So in the rectangular form, we have square root of 2. Cosine of 3 pi over 4 is equal to negative square root of 2 over 2. This sine of that angle will stay as positive because it's in the second quadrant. We have square root of 2 over 2. So by simplifying, we say we will negative 1 plus I. So we are getting the second roots. Now we are going to move for the next roots. Third root where k is equal to 2. So when k is equal to 2, our z2 will be equal to square root of 2 cosine of pi plus our k is equal to 2. If we take 2 times 2, we get 4 pi, then over 4 as our n, then plus I sine pi plus 4 pi over 4. So this one will give us the value of square root of 2. Pi plus 4 pi, we have cosine of 5 pi over 4 plus I sine 5 pi over 4. So this angle, so we can get their exact value. So z2 will be equal to what? We still have square root of 2. Cosine of 5 pi over 4 plus I sine pi over 4. This angle, pi over 4, it is lying in the third quadrant. So in the third quadrant, both those two functions, cosine and sine, will have negative values. So we'll have negative square root of 2 over 2 minus I square root of 2 over 2. This one, if we multiply square root of 2 inside, we stay with negative 1, negative I. So this is the third root of our complex numbers. If it's equal to negative 4, we are moving for last root, which is equal to the fourth root. K is equal to 3. So what will be happening for K, which is equal to 3? So our Z3 will be equal to square root of 2 cosine. What is changing? It is the value of K, pi. So we are moving it to k pi, and k is equal to 3. We have 6 pi over 4 plus I sine pi plus 6 pi over 4. Hence, we have square root of 2 cosine of 7 pi over 4 plus I sine pi over 4. So which means our z3 will be equal to what? This is 3. Index is 3 because k is equal to 3. If we see where those two functions you have, the angle is 7 pi over 4, and this angle is found in fourth quadrant. So if it is in fourth quadrant, so cosine is positive while sine is negative. So we will have square root of 2 times the exact value for this one is square root of 2 over 2. This plus minus I, because this angle will have negative sine I, square root of 2 over 2. Finally, we stay with 1 minus I. So those are the fourth root of complex number minus 2. First root, we get z is equal to 1 plus I. Second root, when k is equal to 1, we obtain negative 1 plus I. For third root, when k is equal to 2, we get negative 1, negative I. While the fourth root, or the roots we need, when z is equal to 3, we get 1, negative I. So simply, this is how we can find the nth root of a complex number in general way. So now we are going to see about some special cases. So apart from that example we try to do to find the roots of that complex number, we may get special cases. Special case we have it is nth root of units. So if z is equal to 1, so we are going to see how we will find the nth root of that unit, or nth root we may find. Know that the argument of this complex number is 1, and the argument of this complex number is 0. So it means the root of that one will be equal to 6, 0 plus 2k pi over n, which is the same as cosine of 2k pi over n plus I sine 2k pi over n, where our k is positive integers up to n negative 1. So let's take an example. Let's take an example. So before we are doing our example, we have something that we have to know for nth root of unity. So the nth root of unity can be used to find the nth root of any complex number by the time one of the roots is known, or one the root of that complex number we are going to find its root are known. And also the sum of nth root of unity is 0. If we try to sum up all the root of unity, we will get is 0. So let's take an example. Find cubic roots of 1. So our complexity, we have it is equal to 1. And you have seen that the decay is equal to 6 to k pi over n. So when k is equal to 0, what will we have? Our z 0 will be equal to what? So our z 0 will be equal to 6 0, or it is equal to cosine of 0 plus I sine 0. By calculating the value of that one, we'll say with 1. So the first root of 1 of the complex number z, which is equal to 1, is 1. This is the first root. So what about the second root when k is equal to 2? So k is equal to 2, our z will be equal to, we have this one, 6, 2. Here k is equal to 1, not 2. When we move from 0, we move up to 1, we have 6 of 2 times 1 times pi over 3. This one will be equal to cosine of 2 I over 3 plus I sine 2 pi over 3. So in algebraic form, cosine of 2 pi over 3, this angle is in the second quadrant, so which means cosine will have negative value, while this one will have positive value. So the value of cosine 2 pi over 3 will be equal to 1 over 2 plus I. The value of sine, this is negative because it is in the second quadrant, while here sine 2 pi over 3, we will have square root of 3 over 2. So when k is equal to 2, we need the only 3 roots. Cubic root of that one, we have is 2. We will have 6 of 2 times 2 pi over 3. This is cosine of 4 pi over 3 plus I sine 4 pi over 3. So what will we have in rectangular form? We have cosine of 4 pi over 3 plus I sine 4 pi over 3. If we check where this angle we have, it is lying in the third quadrant. If it is in the third quadrant, so this cosine will have negative sign, even this one will have negative sign. So we will have negative 1 over 2 plus I, we have plus I, negative square root of 2 over 2, which will give us a negative 1 over 2 minus I square root of 3 over 2. And remember, we have said that the sum of nth root of unity is equal to 0. So the sum of that one of z k must be equal to 0. So we have only 3 roots where our k starting from 0. So let us, root 1 is 1. The second root is negative 1 over 2 plus I square root of 3 over 2. The third root is negative 1 over 2, negative I square root of 3 over 2. So here we will have 1 minus 1 over 2 plus I square root of 3 over 2 minus 1 over 2 minus I square root of 3 over 2. If I try this one and that one will work, will be simplified, you stay with 1 minus 1 over 2 minus 1 over 2 is minus 2 over 2, which is 1. So we have 1 minus 1, which is equal to 0. Thank you so much. So we are continue again. From that side, you have tried to find the cubic root of unity. So as we have said, we are saying that we can use the root of or nth root of unity to find other root of another complex number. So if one of the root of a complex number z is known, so the other roots are found by multiplying that root with the nth root of unity. So an example, using the cubic root of unity, find the cubic root of negative 27. Knowing that negative 3 is one of the roots. So how are we going to proceed? We are saying that we multiply the roots. Solution. So known one root of negative 27, which is negative 3. And the cubic root of unit, we have already found it. One root is 1. Second root is negative, we have negative 1 over 2 plus square root of 3 over 2. So the third root is negative 1 over 2, negative 3 over 2. What we do, we are going to multiply that root, the cubic root of unity. So, and we are saying to get the other root, we have already known one root of negative 27. So, we are going to multiply. So, the first root will be equal to, we take the roots. Unit 1, we multiply by negative 3, so we get negative 3. The second root of negative 27, we take this one, we have negative 1 over 2 plus I, square root of 3 over 2. Then we multiply by negative 3. So we will have, if we multiply inside, we will have 3 over 2 plus I, 3 square root of 3 over 2. This is the second root of that complex number, negative 27. The third root is negative 1 over 2, negative I square root of 3 over 2. Again, we are going to multiply that root negative 3. So finally we get, here we have negative, negative, here we have 3 over 2, but here we have also, here above we have negative, but down we have positive I 3 square root of 3 over 2. So this is how we can get roots of another complex number by the time we have known or one known roots by using the root of unity.